We've just looked at one example of a transpositional cipher called the rail fence cipher, and now we're going to look at another example called the root cipher. So we're going to review the definition of transpositional ciphers in case you've forgotten. We will introduce the concept of null characters that are used in transpositional ciphers. And we will describe the root cipher and then finally do a sample encryption and sample decryption of the cipher. All right, so just recall that a transpositional cipher is just a cipher where the ciphertext is just a rearrangement of the letters of the plain text message, which means that we have the exact same letters in a transposition cipher, the ciphertext, as in the original message, and the letters are just written in a different order. So let's talk a little bit about the basic ideas of root cipher before we get into the specifics. First of all, what we're going to do is when we have plain text, we're going to put the letters of the plain text into a grid, and we're going to do it in an orderly way. For encryption, what we're going to do is we're going to scramble the letters according to some path that you follow through the grid. So we have the orderly way that we put the plain text into the grid, and then we're going to have our weird meandering way that we go through the grid to scramble the letters to get our ciphertext. And for decryption, we do the exact same thing in reverse. We place the ciphertext into the grid according to what the path is that we use to encrypt it, and then we read the plain text off the grid in the orderly way that we originally wrote it. So, what kind of information do we need to know in order to encrypt and decrypt our messages? Well, of course, you need to agree about how to put plain text into the grid. We'll talk about that. That's not part of the key. That's just part of how the cipher works. What do we do if the plain text does not fill the whole grid? We got to have some agreement. The way we're going to handle that is we're going to figure out put some random characters in it to make it work. We have to agree on how big the grid is, what the size of the grid is, how many rows it has, how many columns it has. That is going to be part of our key. And then we have to agree on what the path do we use within the grid to decrypt and also to encrypt it as well. That is also going to be part of the key. So there are going to be two parts of the key. One is going to be the size of the grid, and one is going to be the path. So here's what the key is going to look like. The key is going to be the number of rows and the number of columns in the grid, and it's going to be some type of description of the path among the entries in the grid. And this can sometimes be a verbal description, and it can sometimes be a picture of the grid with the numbers 1 through the number of entries in the grid listed out so that you know which way that you're going through the grid. So for the instructions for the cipher, we're going to put the plain text message into the grid. The orderly way that we're going to do it is start in the upper left entry, fill out each row one at a time, and we fill it out from left to right. And we start with the top row, and then we work our way down to the bottom row. At the end, you may have some empty entries, and we just fill in those remaining spaces with random characters. This is called null characters. They're going to show up here, and they're also going to show up in one of our other transpositional ciphers. And then what we do is once we've put in the plain text, we write the ciphertext by following the path that is given in the key. Each time you take a step down the path, you add that letter in order to the ciphertext. And what this does is it scrambles the letters. Well, it doesn't just scramble the letters. It also might add some null characters thrown in if the message has some empty spaces at the end. And that gives us a nice transpositional ciphertext. All right, so here's an example. We're going to use a key. Remember, I got to tell you how many rows and columns are in the grid, and I got to tell you what the path is. So our grid is going to be 4 by 7, 4 rows, 7 columns. The route that we're going to use is start at the lower left corner, go straight up to the top of the column, move over to the second column, go straight down to the bottom of that column, move to the third column, go straight up to the top of the third column, etc., alternating going down and up the columns until you get to the end. The plain text that we are going to encrypt is called Don't Know Much About History. So here is our grid with 4 rows and 7 columns, and notice that we put in don't know much about history, starting with the top row, working our way down to the bottom row. We have 4 empty entries at the end that didn't fill up because our message didn't fill up the entire grid. And we fill those up with random letters. We're using BPTC. You can use whatever you want. I would suggest using letters where it's clear that it's not part of the message. And here's what the root looks like if you want to look at it in numerical form. So notice on the lower left I have a 1, and as we go up that column, 1, 2, 3, 4, the numbers increase one at a time, and then we move over to 5 in the second row, and then we work our way down 5, 6, 7, 8, and you can see the path going up and down until you get to the very end, which is in the upper right corner of the grid. Now for our ciphertext, we are going to follow that same path in the right grid, but we're going to follow it in the left grid, adding the letters. So for instance, for our first 4 letters, 1, 2, 3, 4 is start at the bottom of the first column, work your way up to the top. If we do that on the left, we get OOWD. For the next 4 letters, you go over to the second row on the top and work your way down to the bottom. That is OMUR. Then you go to the third row, work your way bottom to top, YTUN. On the fourth column, you work from the top to the bottom, TCHB. The fifth row, you go from the bottom to the top, that's PIHK. Are we on the sixth row now? We go from top to bottom, NAST. And then in the last row, you go bottom to top, CTBO. And then you just smash those together, and there's your ciphertext. For decryption, it works the same way, except we just sort of work the process in reverse. We're going to use a different key, different message, so that we can sort of see look at it fresh. So in this case, we're going to look at a 4x5 grid. That's the size of the grid. And now our route's going to be a spiraling route. We're going to start at the lower right corner, go all the way to the outside, and slowly spiral inward until you get to the center. So here's our ciphertext, nice, good-sized message. Here's what our root looks like. Notice that the 1 starts in the bottom. You work out your way 1, 2, 3, 4, all the way around to 14, going around the outer edge. Then once you get to 14, then you start going inside. 14, 15, 16 goes up. 17, 18 to the left. 19 down below that. And then 20 to the right fills up the whole thing. So you spiral from the outside to the inside. So we're going to fill that up with the ciphertext, putting in the ciphertext along the root this time, not top row to bottom row, the orderly way that we do it when we encrypt. So the first 4 letters are going to be QOUK. That's going from the bottom of the right column to the top. Our next 4 are going to go from right to left along the top row, and that's going to be TNOD. Our next 3 are going to go along the first column from almost the top to the bottom, 9, 10, 11. The next 3 are going to be NC and L. Then along the bottom, we get 12, 13, and 14. That's the next 3 letters, OG and Y. Then the next letters going straight up, 15 and 16, gives us IM. Then going to the left 2 for 17 and 18, that's WO. And then the last 2 are 19 and 20, that gives you H and B. Now we write those out from in 1 row at a time, from top to bottom, going from left to right. So our plain text looks like that when we do that. And then we separate them, don't know much biology, and then throw out the Q, because Q is clearly not part of the message. So that was a null character. All right, so now that you've seen these examples, I think you're ready to work on the activities. The name of the PDF file that you're looking for is called root cipher.